A very good morning, everyone. So today we will be discussing on the journal titled First Systematic Assessment of Dental Growth and Development in Archaic Hominin, genus Homo from East Africa. So this was a study which was published in 2019 in the journal Science Advances, which has an impact factor of approximately 14 to 24. And this study, the terminologies used in this study are pericymata, which are nothing but the growth lines in enamel reflecting incremental development, and the crown formation time, which is the duration of enamel deposition, and long period line periodicity, where the interval between the red CS line, that is 10 days in this study, is studied, and the neonatal line is the mark of birth in dental histology. The novelty of this study is this is the first study, this is the first systematic assessment of dental development in the East Asian archaic hominin population. And the methodology which is used in this study is the high resolution synchrotron microtomography, the phase contrast microscope for non-disruptive analysis. And the findings of the study revealed modern human-like dental growth patterns in a morphologically archaic hominin population. So the aim of the study was to compare the dental growth trajectories of juvenile to Neanderthals and modern humans. So objective was to quantify crown formation time, the pericymata distribution, and the root extension rates. So it also estimated the age at depth and M1 eruption timing. And this study has also tested the hypothesis about life history evolution. So the materials used in this study are firstly the sample and the fossil context. The specimen was the Sujiayo 1 junior maxilla, which was taken. It is an archaic Homo species sample from China, and it was approximately 161 to 224 Ka, or that was the time period. And teeth analyzed was the permanent teeth, which involved one incisor canine, 3 premolars, and 1 molar, which was all fully erupted, and 2 molars, which were incomplete. The crown was incomplete, the formation was incomplete, and deciduous teeth, the deciduous canine and deciduous 2 molars, the roots only were absorbed, and the comparative data comprised of modern humans from South African and Newcastle population, and Neanderthals, that is the Neanderthals, Homo erectus, and POPCC hominin population. So the imaging techniques which we used is the PPCSR micro CT, that is propagation phase contrast synchrotron microtomography. So the resolution used was 0.742 micrometer. That is for the neonatal line, and 6.34 micrometer for studying the general enamel features. And the beam line was IED 19 and the European synchrotron radiation facility. And the key applications were it identified the neonatal line in the maxillary parapon, and it measured the daily secretion rates and the long line periodicity for 10 days. And the laboratory microtomography, the resolution was 43 micrometer, which was used for studying the development staging. And this was the software which was used, the VG Studio 2.2, this was used, the software was used. And the key measurement protocols that were used were crown formation time. The cuspal enamel thickness was measured from the dentinal horn to the first pericymata, and the lateral enamel, that is the pericymata, found in the periodicity for 10 days were studied and noted, and age at death estimation was also done. The postnatal cuspal time, that is the molar 1 parapon formation time, that is 315 days minus the prenatal enamel formation, 18 days was studied. And in lateral enamel, the cross-matched LEHS, the linear enamel hypoplasia across teeth was studied. And totally the days were all studied, and it was minus with the 47 days, which was the formational period. So there they have given results. The root extension rate was also studied using formula. There were various formulas used to study and study these values, and the root extension rate, the formula used was the root length micrometer divided by the root formation time in days that was taken into account. For example, like molars, the root extended at 9.74 micrometer a day versus today's date it only takes 6.28 micrometer per day. So that is how it was studied. And comparative analysis was also done in regard to perichimatic distribution and initial timing, which will be later discussed in the statistical part. So, moving on to the regression models, moving on to the statistical analysis, regression models were studied. So they studied about the daily secretion rate, that is DSR gradient. Linear regression and its application was done to predict the cuspal formation times across teeth, and error estimation was done. Inter-observer variability for perichimata counts, crown formation time and root extension rates were seen. And age and death uncertainty was also studied, which was plus or minus 47 days. It was propagated from the perichimata or the enamel hyperplasia counts. And the comparative statistics was also done. So modern human ranges, it is from crown formation time. So the Giglio values it compared to pooled modern data, it was compared and studied. And the molar eruption time was also noted at the 6 years with modern range of 5.1 years. And the Neanderthal contrasts were also studied. The perichimata distribution it falls outside the Neanderthal range, except the premolars. And the root extension, as said, it was 9.74 micrometer per day, which was greater than the Neanderthals, which was approximately 6.3 micrometer per day, which is comparatively higher when compared to the modern day Homo samples. So the results of the study were, they noted that modern human leg trace, that is prolonged crown formation times, example for molars it takes 3.03 plus or minus 0.01 years, and there is delayed molar eruption, that which is approximately around 6 years noted in today's world. And perichimata distribution, it is 60 to 65% in cervical half. It aligns with that of the Homo sapiens. Deviations are also noted, that is deviations in rapid root extension rates are noted, and late lateral initiation was also there. That is, there is a period of lateral period of 318 days. And the statistical robustness was also put forth, stating that linear regression for DSR gradients were there, and cross validation via LH matching was also done. And the discussion, moving on to the discussion, the Giglio dental development, it aligns closely with modern humans in prolonged crown formation times and delayed molar eruption, which is around 6 years, and perichimata distribution, which is 60 to 65% in the cervical cavity. And deviations from this results, it charges mosaic evolution, that is rapid root extension rates, that is 9.74 micrometer per day, which is approximately 6.3 micrometer per day in modern humans. And lateral late L1 incisor initiation, that is 318 days, a rare pattern even in modern humans. So the strength of the study is that they use cutting edge methods like synchrotron imaging for high resolution histology, and the comparative framework like broad taxonomy comparisons in Neanderthal, Homo erectus and modern human population. So the another strength was it integrated paleontology, developmental biology and life history theory. The limitation was the sample size was just one juvenile sample. No adults or other East Asian Archaic Homo samples were included. So the assumption is it was only fixed to a 10-day study periodicity, and no environmental stresses were analyzed. And taxonomy, the partial root preservation limits some measurements, and future direction is they can analyze more East Asian fossils and compare it with other populations too, and they can investigate genetic basis of developmental rates, genes like FOXI3, and environmental context can also be studied to link the dental stress markers to paleoecology. So they concluded this study by saying Hominin, it exhibits modern human-like dental growth. Despite its archaic morphology, it indicated independent evolution of prolonged development in East Asia. And mosaic traits, that is the fast-growing root growth, it hinted unresolved taxonomic diversity. So the implication is in implication in regard to paleoanthropology is it provides models of East Asian hominin evolution. Possibly it is a distinct lineage or a hybrid population. Evo as seen in the previous JCs, the dental histology can decouple morphology from development and timing. And future work is more fossils and ancient DNA. They are needed to test in Desovian and hybrid hypothesis to come to a proper conclusion. So the bottom line is this future blurs the line between the archaic and the modern growth patterns. It urges a caution in linking the dental traits to taxonomy or life history. So this study borrows some elements from stroke, like the transparent methods or results, but it is not a perfect fit for scope guidelines or tripod guidelines. Tripod is something which we use for the archaeological studies, and so here it prioritizes paleontological and emerging standards over epidemiological framework. So the study design was good. We tested the life history hypothesis. The sample is that was only one juvenile sample was taken, and the EDJ was well preserved in the sample. The methods were all clear and well documented. Variables were also good, and the results reporting, they stated that it will be only available on result, but the R-square values were provided. Interpretation was well discussed. Custom R code was not provided, so this study cannot be reproduced. And yes, this study linked development to life history evolution. Thank you.